Today we will discuss the magnetic effect of current. Magnetic effect of current. Magnetic effect of current means if there is a current carrying wire, carry a current I, then it create a magnetic field in its surrounding. ঠিক আছে? Okay. If there is a current carrying wire carrying a current I, then it creates a magnetic field surrounding it. But it does not magnetize. That is, the magnetic wire does not form a magnet, but creates a magnetic field in its surrounding. This case was first discovered by Oersted, which is called Oersted experiment. What is experiment? Oersted experiment. Say that there was a magnetic needle aligned freely along north-south axis. A current carrying wire is over the magnetic needle. Now it can rotate freely, this magnetic needle. As a current I flowing through that conducting wire, then this needle deflect itself along this direction. That is, now this is the new position, n dash is dash. So we can say that current carrying wire creates a magnetic field. Why? Because north-south pole of a magnetic needle creates its own a magnetic field surround to it. Now this previous magnetic field is only affected by any other magnetic field. As we flow a current I, then the needle deflects. That is, this current carrying wire creates a magnetic field. This magnetic field affect previous magnetic field created by the compass. So we can say that from the Oersted experiment that a current carrying wire creates a magnetic field surrounds to it. Okay. Now we have to find the strength of the magnetic field or the value of the magnetic field which is created by this current carrying wire. This is given by Bioshock Law. Now we study the Bioshock Law. Okay. Bioshock Law. What it say? This law says that if a current carrying wire, this current flowing through it I, now we can consider a small part dl, which the small part, that means we can say this is a straight line part. Now we have to find magnetic field created by this wire or this current element part at a distance r vector at point P, which makes an angle theta with the dl vector. We have to find magnetic field at that point. Bioshock Law says that this magnetic field, let dB, will be proportional to the current which is flowing through the where dB proportional to sine theta, dB proportional to 1 by r square, and also dB proportional to dl. This is the Bioshock Law. Magnetic field created at the point P will be proportional to I, proportional to sine theta, and inversely proportional to the square of the distance, and proportional to dl. Combining these four proportionality part, we can write an equation dB proportional to I dl sine theta by r square. Now, as there is a proportionality, so there will be a proportionality constant, that is dV is equal to mu naught by 4 pi I dl sine theta by হচ্ছে r square. What is mu naught? This is a proportionality constant but not dimensionless constant. It has a dimension. Now, what is mu naught? Mu naught is the magnetic permeability of air or vacuum. Mu naught is the magnetic permeability of air or vacuum. What is its value? Its value is 4 pi into 10 to the power minus 7. Now unit of magnetic field, that is Tesla or Weber per meter square. Tesla or Weber per meter square. Vector quantity, this is a vector quantity. The direction will be find sometimes later. But now magnetic field magnitude mu naught by 4 pi ideal sine theta by r square. This is the SI form. Okay. Unit of magnetic field Tesla or Weber per meter square. Now we remove this. Okay. So we find that dV is equal to mu naught by 4 pi ideal sine theta by r square. Now we have to find the dimension and unit of mu naught. Unit of magnetic field Tesla or Weber per meter square. Current we know SI ampere. Distance, some distance, this is meter. So V dV is equal to mu naught by 4 pi ideal sine theta by r square. We can say that unit of mu naught will be unit of mu naught will be dV Weber per meter square r square multiple, that is Weber per meter square into meter square by I dl. I means ampere, dl means meter. So this meter square cancel. So now will be Weber per ampere meter. Weber per ampere meter. This is the unit of mu naught. Weber per ampere meter. Now the dimension. We have to find the dimension of magnetic field. Dimension of magnetic field is some. Later we found that magnetic field and force on a charged particle related q v cross b f vector. Force on a charged particle moving in a magnetic field will be q v cross b. From that point, F Newton, V meter per second, Q coulomb, all are SI. So dimension of B will be F by QV. F means m L T to the power minus 2 by Q, that means I into T, V L T inverse. So here T inverse cancel, IL. So we find that ml T to the power minus 2 by I inverse or L cancel. So m T to the power minus 2 I to the power minus 1, m T to the power minus 2 I to the power minus 1. Okay, force ml T to the power minus 2 q I into T, v L T to the power minus 1. qv means I into L, T inverse cancel, ml T to the power minus 2 by I into L, so I inverse, L cancel, so m T to the power minus 2 I inverse. Now dimension of mu naught, dimension of mu naught. Now dimension of mu naught, we found that dB equal to mu naught by 4 pi I dl sin theta by r square. So mu naught dimension will be dimension of dB magnetic field m T to the power minus 2 I inverse into r square L square by I, dimension of I dl L. So m L T square I to the power minus 2, ml T square I to the power minus 2. This will be dimension of the mu naught. Okay. Now the vector form of Bioshock Law. Okay. Vector form of Bioshock Law. Again, this is the current carrying wire. Here is a small part, dl vector, r vector, this is theta. The direction of the magnetic field, as the magnetic field is a vector quantity, so there will be a magnitude and also a direction. Direction, for finding the direction of magnetic field, we use Maxwell corkscrew rule or right hand grip rule. What it say? If we use the thumb of right hand along the direction of the current, then the forefinger other than thumb will represent the direction of the magnetic field at some point. As the point is here P, so we use thumb as a direction of the current. So here fourth finger towards down, so the magnetic field is here downward. Downwards means plane of the paper is this, so perpendicularly downward. Perpendicular downwards we show in cross notation just. Here, if here is a point Q, so here is this R vector, R dash vector, let's say. So now this is the direction of current, so we have to find at that point. So here 4 fingers are upwards, perpendicularly upwards, so this will be dot. Perpendicular upward means we use dot, and perpendicular downward we use cross. Now the angle between DL and R is theta, and the form is dV is equal to mu naught by 4 pi I dl sin theta by r square. Now if we multiply r in numerator also in denominator, then dB will be mu naught by 4 pi I dl sin theta into r by r cube. Now dl and r, two vectors, and angle between them is theta. We know that two vectors if a vector and b vector, and angle between them if theta, then a cross b gives magnitude of a cross b means ab sin theta. Now here dl and r, two vectors and angle between them theta, so dl r sin theta gives the magnitude of cross product between dl and r. But here dl cross r or r cross dl, which is correct? We have to find the direction correctly, then we can say that. Here dl cross r means with dl cross r, right hand thumb rule we applied. dl cross r means then it gives perpendicularly downward, but r cross dl here perpendicularly upward. Here we find that magnetic field is perpendicular downward, so dl cross r is the correct. Clear? So here we can say that dB vector is equal to mu naught by 4 pi I dl cross r vector by r cube. This is the vector form of Bioshock Law. Okay.